Hello everyone. Now welcome to another video. Now in this video, I'll be providing solution to this magnetic field question. So we have another question on magnetic field, and this is another question about what we call the cyclotron, particle accelerator. When we talk about particle accelerators, that is when we have when particles, or that's charged particles, are accelerated to a very high energies in electric field and magnetic field. So that's what we call particle accelerator, and we have different types of particle accelerator. One of them is what we call the linear particle accelerator, and we have another one known as the cyclic particle accelerator. So an example of linear particle accelerator is the one we call the drift tube particle accelerator. Then when it comes to cyclic accelerator, particle accelerator, then we have what we call the cyclotron. So it is in cyclotron the charged particles are forced to travel repeatedly through a modest electric field by the action of what we call a transverse uniform magnetic field. So and these particles they will acquire energy in small proportion and ultimately what accumulates to a larger amount. So that's in the case of cyclotron. Now in this question we are asked to we want to calculate the cyclotron frequency and also the maximum speed required by the proton. Now let's look at the question. We have a cyclotron designed to accelerate protons has a magnetic field with a magnitude of 0.450 Tesla. So the first thing is, now let's write down the values of the parameters. So we are given the magnetic field intensity, or you can call it the magnetic flux density, which is 0.450 Tesla. Now also we are given the radius of the particle when as it describes a circle along, that's a circular orbit along its path. So we have radius. The radius is given to be 1.20 meters. So now what are the cyclotron frequency? Now in this case we want to calculate the cyclotron frequency. Now that is cyclotron frequency. Now the cyclotron frequency will be omega, that's W, and that will be what we are looking for. That's the unknown value. So to be able to calculate the cyclotron frequency, the frequency of a charged particle such as proton, describing a circular orbit along its path when it is moving in what we call a transverse uniform magnetic field, will be independent of the velocity of the charged particles. So now the frequency will now be, that is, now we know that for the linear frequency we have F to be equals to EB all over 2 pi m. So where m in this case becomes the mass of the proton. Now what is mass of proton? Mass of proton is what? 1.67 times 10 raised to the power of negative 27 kilograms. Now we also need to write, we also need the value for the charge on proton. Now we know that the charge, the magnitude of the charge on proton, is 1.602 times 10 raised to the power of negative 19 coulomb. So now, but because we are looking for the angular frequency, so to be able to calculate the angular frequency, so this equation, this formula will now become W equals to EB all over M, that is MP. That is, we know that omega is 2 pi f. So 2 pi f is now what we have as W. So we have W to be equals to the charge on proton, which is 1.602 times 10 raised to the power of negative 19. Then multiply by the magnetic flux density, also known as the magnetic field intensity, 0.45, okay, all over. Now the mass of proton, now mass of proton is 1.67 times 10 raised to the power of minus 27 kilograms. So this will be in radians per seconds. It will be in radians per second. So now let's multiply the numerator, 1.602 multiplied by 0.45. Okay, so this will be 0.7209, okay, times 10 raised to the power of minus 19. Then divide by 1.67 times 10 raised to the power of minus 27. This will be in radians per seconds. In radians per seconds. Okay, so let's divide this value by 1.67, okay, and that will be 0.431. W equals to 0.431, okay, times 10 raised to the power of minus 19 plus 27, then in radians per second. So W will be 4.31 multiplied by, now this will be minus 1, okay, then multiply by, this is minus 19 plus 27, that will be 8. That will be 8. So that W will be 4.31 multiplied by 10 raised to the power of 7. And this will be in what? In radians per seconds. So this is the frequency of the cyclotron. Now the second question, okay, now what are the maximum speed required by the proton? So to calculate the maximum speed required by the proton, now we know that the force that keeps the charged particle moving in a circular orbit will be the what? Centripetal force that will always keep the charged particle, you know, directed towards the center or moving along its path. Okay, so that force, so to calculate the maximum speed, so let's say the maximum speed, so we can say let's V equals to the maximum speed. Okay, so we know that now for us to be able to calculate the maximum speed, we are going to have the centripetal force to be equals to EBV, okay, just like QVB. Okay, so in this case we have the centripetal force to be mv squared over what? Over r equals to EVB. So dividing both sides by V, now this equation reduced to mv over r equals to EB. Now, so now let's express V in terms of what? In terms of B, M, and R. Okay, so we're going to have V to be equals to EB over what? Or EBR over MP. Remember, it will be MP because we have here that what we have here is what? Mass of proton. Okay, so this is the velocity. So we have the velocity, okay. The charge on proton is 1.602. 1.602 times 10 raised to the power of minus 19. Okay, then the magnitude of the magnetic field is 0.45. 0.45. Then multiply by the radius. The radius is 1.2. Okay, 1.2 all over the mass of the proton, which will be 1.67 times 10 raised to the power of minus 27. Okay, so multiplying the numerator, 1.602 multiply by 0.45, then multiply by 1.2. Okay, that will be, so we're going to have V equals to 0.86508 times 10 raised to the power of negative 19 over 1.67 times 10 raised to the power of minus 27. So let's divide this value by 1.67. Okay, when we do that, we're going to have V to be 0.518 times 10 raised to the power of minus 19 plus 27. And the unit of this is the what? Meters per second. so that this will become 5.18 times 10 raised to the power of -1 plus 8, because 27 minus 19 is what? Is 8. So -1 plus 8 in meters per second. So the velocity will be 5.18 times 10 raised to the power of 7 meters per second. So this is the maximum speed, okay, required by the proton. The noblest pleasure is the joy of understanding. Bye bye.